So yeah, this is DevOps as engineer empowerment. Sorry that the links are in blue. I know that's convention. This got converted to the PowerPoint format, so there's some font stuff going on. Okay, so who am I? My name is Sam Handler. This is my first conference talk, so you're welcome for that. Enjoy. I want to take a second to thank the ChefConf staff, Mandy, everyone in this room, the public transportation operators, the people that are putting out the chairs, the people that are catering. A lot of work goes into these events, and very little of it has to do with me, but now I get to talk, so cool. I am a DevOps engineer and a consultant. As a consultant, I invite you to blame me for any problems that you may have, or if this talk is not good, you can blame it on the consultants, which is a traditional move. My consultancy is called Ponderosa.io. It's a training-focused DevOps consultancy. The idea being that we don't just go in and set up your chef cookbooks. We also make sure that you really know how all that stuff works so that you're in a position to really do good work going forward. Yeah, you can find me on Twitter at PlantFanSam. Big fan of plants. That's why the company is called Ponderosa. It's a type of pine. Also, if anyone hasn't seen the pine tree on Pine Street, it's there. Looks really cool. So go and check it out. All right, last thing before we get going is that like 13 of the slides in this presentation have animals on them. So if you find yourself bored, just wait for another one of those. So here's number 2. Okay, so this is a dog that is like very surprised that there's no chef in this presentation. There's no chef in this presentation, so if you want more chef, hopefully you're all chefed out by this point, but whatever. All right. So I will start with a familiar story, and for my first conference talk, I'm going to do the thing that you're not supposed to do, which is read directly from the page in front of you. Without further ado, here is a familiar story. After getting an ultimatum from the VP of Engineering to, quote, finish this Kubernetes thing, by the end of the quarter, the quote-unquote DevOps team went heads down for a couple months and finally deployed a legacy app to the new platform, Kubernetes, perhaps you've heard of it. Backs are slapped, champagne is poured. The team finally has the deploy button they've dreamed of. After years of weekly releases, they're now releasing multiple times a day. Mindful of meeting the put everything on Kubernetes deadline set by the VP of Engineering 2 quarters ago, the DevOps team uses its learnings to start Kubernetesizing another application. Then, a few weeks later, an engineer deploys the first app, while the entire DevOps team is, surprise, surprise, at lunch. The site worked fine locally, but you guessed it, crashed in production. The app boots, but not 500s on every request due to a missing environment variable. The DevOps team didn't have time to build out a fully functioning QA environment, or the developers would surely have caught the error. The on-call DevOps engineer's phone starts blowing up, and the alerts channel in Slack goes nuts. The engineer tries rolling back, but the deployment pipeline always grabs the latest version from the repository, so that's not an option. They revert the pull request with the breaking change and wait for a Docker image to bake the rolled back version so that they can deploy once again. One engineer remembers something about a CLI, using a CLI for environment variables. But wait, what's a kubeconfig again? On Slack, a DevOps engineer suggests a command for the application engineer to run to roll things back, but the engineer gets a 403. He doesn't have permission to make this change. 10 minutes pass. Docker builds sure take a long time. As the Docker build finally finishes, the DevOps lead runs into the room panting, the crust of a pizza slice in hand. The engineer spots him and tells him the environment variable to set. The lead unlocks his computer and runs a command to get the site back up. And scene. So, how do we avoid this situation? In this photo, the situation is that dogs have gotten into a trash can and have eaten everything inside of it. The situation with the website is that it stopped serving web requests successfully. To clarify, I am not above this type of situation, either eating out of the trash or causing a website to be down. This is an amalgam of different kind of situations that I have unfortunately been involved with. And the core problem of the story, in my opinion, is that the developers weren't empowered. Without power, they could not take responsibility for the health of the application. Just kind of going point by point, the easiest way to give the engineers more control would be to have written a better rollback mechanism, which, by the way, is a native feature of Kubernetes at this point, but they didn't have it. Furthermore, the DevOps engineers were the ones that were getting the alerts, indicating that the DevOps engineer is the one that is responsible for fixing the problem. And finally, the engineers were not properly educated on the new deployment strategy, largely because the DevOps team was heads down on its work. The DevOps team didn't even get a chance to clean up their pipelines because they had to go and put the next thing onto Kubernetes. And I think that there is a good way to avoid this kind of situation. Enabling shared responsibility by empowering developers. This sounds like gross corporate speak. Does anyone here work for a corporation? Yeah, right, okay, cool. So we all work at corporate, well, I am an independent, I am an LLC. One day I will grow into a corporation. But yeah, it seems a little, but I actually believe that this is true. So what do I mean by shared responsibility? All engineers are responsible for the availability, stability, and the performance of the application. And that includes front-end engineers and back-end engineers. And I want to point out that sharing responsibility is an aspect of organizational culture. It's something that you can do without DevOps tooling, but something that DevOps tooling makes a lot easier. And what about empowering developers? By that I mean giving developers the tools and education and context necessary to maintain and change their application or their platform safely. This doesn't mean that application engineers are going to all of a sudden have privileges to do everything, because that won't work. It's highly contextual. So with this in mind, how do we get there? We want to get out of the superhero business. On the left, you have a dog dressed as Batman. On the right, you have a dog dressed as Wonder Woman. These are superheroes, and this is what we do not want to be. And so what do I mean by the superhero business? The first, well, there's one of those PowerPoint problems I was talking about. The first is being the only team with proper visibility into and interest in system health. The next would be being the only one that knows how to fix catastrophically broken systems, being the only one responsible for fixing broken systems, and being the only one that has permission to fix catastrophically broken systems. DevOps cannot be the only one that can fix or substantively change the platform if you want your engineers to be responsible and empowered. And so if you take nothing else from this talk, please don't leave immediately after I say it, but this is like the important thing is ask yourself, how do I get out of the superhero business? Does anyone, I've been in a lot of talks where people are like, raise your hand if you feel like you're in the superhero business. So I'm not going to do that. But think to yourself, am I in the superhero business? Do I consider myself a superhero at some times because I am the only one that can do this thing? What you got to do is figure out how to fix that problem. Make it so that you're not the superhero. So the rest of this talk, I'm just going to discuss different ways that you can leave the superhero business. These are things that I've found effective in making my life easier so that other developers and engineers can handle the problems that I shouldn't be the only one that can solve. So the first one is educating engineers. The long-term way to get yourself out of the superhero business isn't like taking yourself down a peg and not being a superhero. It's actually making more superheroes. And as DevOps engineers, our superpowers are often like knowing how to like write an Nginx config that you found on Stack Overflow and then modified for yourself. So like these are like not necessarily difficult skills to master. I don't want to trivialize the state of the art or whatever, but you know what I mean. One note is that this requires rejecting some of like, some of the ops half of the DevOps, the ops half of the like DevOps portmanteau, which is like the legacy of like the wizardly system administrator. I don't know if any of you have worked with one of this type of individuals, but someone that like is drinking a lot of Mountain Dew and is like, no, you can't SSH to that box because like I'm the only one that knows how that thing works. You got to get completely out of that mindset, like 100%. Our job is to make sure that developers are empowered to make changes, and if you are restricting access because of being territorial, that's a problem. So instead of being a DevOps wizard, what you want to do is be a little bit more like Hogwarts. You want to teach people how to do the things that you do so that you don't have to do them. So the good news is that the surface area of your platform is going to be limited, and applications within your platform, whatever you're responsible for, are going to have finite bounds. So you can really target your educational efforts. So I want to just talk about, I'm pretty sure all of the core education areas are going to show up at once, so only read the first bullet. Oh no, look at that. All right, so the first thing you want to do is educate your engineers on what your application runs on. For people that recently graduated from boot camp, or people well, just pretty much any engineer that doesn't have DevOps experience will have some degree of curiosity. Where does this code actually run? And it ends up being a really interesting question that gets to the core of your business. Maybe you have to run in a data center in your own data center for regulatory reasons, or maybe you just made the switch to Docker Swarm or Kubernetes or whatever it is. This is a really interesting question that you want to educate developers about. And once you know where it runs, it's important to teach developers how the request actually makes its way from, and this is assuming you're running a web application, but maybe you're not. Maybe you have another sort of interface. But how does a request actually reach the application, and how is that request returned? Or how does the response make its way back? So this will run the gamut from setting up like a ELB, and then that gets forwarded to an EC2 instance. That's really, really interesting stuff that seems very boring to many DevOps engineers because we do it all day. But it's really, really important for the rank and file engineers to understand how this works so that they can debug issues. The next big one is, what does deploying mean? So if you strip away all of that abstraction and you give the team a deploy button, it's really helpful to tell them, okay, what does this deploy button actually do? Because they're going to make code changes that require knowledge of deployment mechanisms from time to time. Maybe they have to run a migration, et cetera. And this is really useful information for them to have. And the final one is, how do we monitor? If you want the engineers to be responsible for the health and welfare of the application, then you need to teach them about where do you see CPU usage, all of that. And I'll talk about that a little bit more later. So given these educational objectives, there's a few different methods that we can go through to how do you make this education happen, especially without interrupting your normal workflow? Well, unfortunately, you're going to have to do some interrupting of your normal workflow because otherwise nothing will happen. But I think that a lot of them are pretty minor changes. It doesn't really take much to get a developer to learn something. That is their entire job. Most likely the language that they are writing in hasn't been around for longer than 5 or 10 years. They're probably learning 5 or 6 JavaScript frameworks at this very moment. It's like a built-in part of the developer mindset to be curious about tooling and software. So that's great. And also, DevOps engineers, we like easy tools, right? We like Terraform because there's 2 commands that you have to run. So it's not that, there's a lot of intuitive tooling that they can learn pretty easily. Always prioritize documentation and good writing. If you have a repository that gets deployed, make a note of how it's deployed. And don't just throw some stuff in there as part of the original PR. Revisit it, and make sure that someone that's visiting a repository for the first time really knows what's going on in the DevOps context. A very useful tool, which is pretty informal, is just having whiteboard sessions. So depending on how many engineers your organization has, These might be like group whiteboard sessions, or it might be part of the onboarding of an engineer to a product team where they go to the DevOps, they sit down with one of the DevOps engineers, and the DevOps engineer sketches out the entire platform, or some subset of the platform, depending on how large your corporation is. But having that moment to basically say, okay, like take a step back. You've been looking at individual files in a Rails code base, and I want you to take a second, zoom out, think about, all right, a request comes in to this load balancer, this goes to this DNS record, which goes to this load balancer, and then that goes to the Rails application, and that queues something through this Redis. Don't underestimate how important this is and how trivial an amount of effort it can be on the part of the DevOps engineer. You have all of this knowledge in your head, and you just need to take 30 minutes and sit down and draw it out on a whiteboard and give engineers an opportunity to ask questions. Getting into a little bit more obtrusive or involved methods, you have pair programming. If you're not familiar, most likely you are, it's you just do your job with someone sitting next to you. And this is a pretty good way, assuming that you pick your task really carefully. If you're like doing some sort of really laborious configuration that you wish you didn't have to do, you probably don't want to make someone else sit through that. That's why you're getting paid. But if you select something carefully, then you can really educate engineer pretty quickly. So an example would be if you're writing a cookbook, a new cookbook, and sitting down with an engineer that doesn't know what chef is gives them an opportunity to really learn. Last one I'll talk about is rotation programs. These can kind of go two ways. The first one is you've got this works if you have like a larger DevOps team, but if you have like 7 DevOps engineers on a DevOps team, then you can have one of them go and visit a product team for a period of a month or 2 months, and they basically pair with the engineers on that team and help them with their DevOps tasks, thereby transmitting some of that DevOps knowledge, which is pretty cool. The other way that this can go is if you have a smaller DevOps team and you don't have that many resources to lend out, then you can basically say, all right, 3 months after you started our company, you're going to rotate onto the DevOps team, and you're going to stay there for 1 or 2 months until you learn X, Y, and Z, and then you're going to go back to your team. And I've seen this work on a couple of clients, and basically we had an engineer that just started, and he got oriented, set up his laptop, and then he came onto the DevOps team for 2 months, and then he went back to the product team that he was on, and then all of a sudden in 3 weeks their application was running on Kubernetes, where previously it was running on EC2, which is great. So those rotation programs are a pretty good way of you don't have to drastically rethink how you're working if you have a rotation program, but you need to just make yourself very available to educate the new team members. So that can be easier than setting up like a wholesale training program. Oh, and also external trainings for specific tools. My consultancy does offer trainings, but this is not a vendor pitch. It's sort of a waste of a DevOps engineer's time to teach people syntax and stuff like that sometimes. If you know that you want your application engineers to learn sumo logic, or if you want them to learn how to do whatever it is, then you can probably just pay for them to take a course somewhere. And that does a whole lot of good. All right, so I guess I'll drink some of this water. Once developers have some idea of what they're doing, or even before that, it's really good for them to have a place to try stuff out. I'm going to call that a playground. This is a dog on a slide. That's a playground, having a great time. And I want to just spend a couple seconds defining what a playground is. It's not just staging, mostly because depending on your setting, staging may be like a pathway to production thing. So if you're use these SSH credentials to get onto the staging box and do whatever you want, that can interfere with the path to production and also raise the stakes for what should be a low pressure learning experience. second facet of this is that a playground is going to be an isolated environment that runs like all of the application components. You don't want to just, if you have like a web server and 7 microservices and your playground has like a web server and 2 microservices because the rest of them are like too hard to set up and then the app doesn't really work in a full functioning way, that doesn't quite work for these purposes. You want to have the same deployment strategy for your playground as you do for production. Same Jenkins job, same TeamCity job, what have you, so that the engineers will get used to using that same control plane so it feels familiar when they're transferring these skills to a production environment. And the developers will have the maximum allowable access to this playground. So here's a place where, okay, so for compliance reasons, you need to restrict access to certain servers. In a playground environment, hopefully you can cleanse the data such that developers have maximum access to play around and basically be their own DevOps engineers and do their learning that way. So briefly, why is this important? Because DevOps tooling is extremely scary and needs to be learned if these engineers are going to start really taking responsibility for the application. The reason that DevOps tooling is scary is that it has a huge blast radius. Like if you mess up DNS, like your website goes down sometimes. So like that's a good thing to keep in mind for engineers that are just learning this stuff for the first time. And it's also like an unusual domain. A lot of engineers are spending time in IDEs. They're not spending a lot of time like running a bunch of bash scripts and piping things to awk and all that kind of thing. So it's an unusual domain as well. So giving a safe place for developers to try stuff out is really important. The other reason you want to supply them, or one other reason, is that full platform setup, like the aforementioned app with 7 microservices, if you're just learning how to use AWS and someone is like, here, like play around on AWS by setting up our entire application, our entire like platform with all the microservices, like that's a lot to learn really fast, and it's not really realistic to have an engineer set that all up themselves. But if you do that for them, then you can have them do their learning in a production-like environment. So everything that they do in like a playground environment will all of a sudden be transferable to the production environment. And that comes into play here, which when the engineers start to really imbibe the DevOps methodology and they're testing out changes that span both, I don't want to say hardware and software, but that span like, infrastructure and software, where okay, maybe they want to sub out this microservice for a new serverless component that like AWS has just invented. A playground is like a good place to do that, and not something you can't really do that on your laptop necessarily. So once you have a playground set up, and once you have engineers that are a little bit more educated, you have to give visibility into like what is going on. So these 3 dogs are looking at a monitoring dashboard off to the right here, approximately where I'm standing. And this is to illustrate the point that we want to make monitoring and instrumentation accessible to engineers. The goal is to give engineers an understandable view into the health and performance of the platform. And the reason that we want to do that is because engineers have to have visibility if we want them to be responsible, right? It's not reasonable to be like, bless you. It's not reasonable to be like, can you like watch my kid, but then like don't tell that person where the kid is. So this is like step 1. Also, I don't have children, so I don't know if that's good advice or not. Yeah, so if monitoring is like a DevOps thing, then uptime is a DevOps thing, which means those are your nights and weekends. Further, the monitoring has to permeate the entire organization. You can't just have monitoring available. You really have to like make it part of like the lifeblood of the organization. Some ways to do this include like having canonical dashboards. So being like, this is the dashboard. Maybe you have this dashboard displaying somewhere, in your engineering department offices. You also want to like delete Cruft from like whatever you're using for monitoring. I'm a big Datadog fan, but like you want to make sure that like the dashboards in Datadog are not just like SAM final PDF kind of stuff. You want it to be actually important things for your engineering team so that you can point people to that and say, this is where we monitor our stuff. And lastly, sensing a theme here, you want to provide a little bit of training. Not a ton. Remember those like 30-minute whiteboard sessions? This is like even less than that. If you imagine someone that did not get a computer science degree like me, and that like maybe used to be a professional blogger, which was like my job, or graduated from boot camp or whatever it is, there's not like a intuitive understanding of like CPU, RAM, all that kind of stuff. And so if you're showing someone your like canonical dashboard and you're like, okay, so here's like the 500s coming from the ELB, and here are the 500s coming from our web application, you're gonna need to spend a little bit of time teasing out like, okay, what is an ELB? What is our web application? What is a 500? How is this thing getting this data? But again, these are like pretty minor, if you're having a one-on-one conversation with someone or you're working with a small group, you can get these points across pretty quickly. And finally, I just want to point out that if you buy into this thing where you're like monitoring should permeate the entire organization, you can use instrumentation as a lever to make this happen. So you can say, all right, I'm going to show you how to graph every time that this function is called. And see this like sample graph in Datadog? It shows that like this function has been called 75,000 times today. Obviously, that's not a particularly good thing to keep track of in Datadog, but it's a good way of saying this application that you're running, you can actually do custom metrics for it, and you should be aware that that's an option. And this is like a dashboard where you can actually see that in action. So, I'm going to drink some more water. So, up until this point, we've kind of like talked in like training, playground, safe mode. And I'm going to transition to the slightly scarier mode, which is giving appropriate privileges. This dog is living free and easy, but also wearing like a nice little coat, protecting it from the elements, maybe somehow related to privileges, but definitely just a cute dog. The first thing that you want to think about when you're thinking about limiting access to your systems is why you're doing it. And as far as I can tell, there are two reasons. I'm not a security expert, but the two ones that come to mind for me are security. So you don't want production data available to just anyone. And so depending on the size of your engineering team, you may not want production data to be available to them, or you may not want people to be able to see network traffic because who knows why, whatever, that's your own thing. The other reason is stability. You are scared that, or maybe you're not, but if you're restricting access for stability's sake, it means that you're worried that people with elevated privileges are going to break the system. This is part of the sysadmin wizard heritage where it's like, I don't want to give you pseudo access on that box because you're going to mess everything up, which is completely valid as a perspective, but also, you're going to want to be aware that that's what you're doing. So I'm really not making any commentary on, which of these is more valid or whatever. I just think that it's important to be honest with yourself as like a DevOps team, as an engineering organization about why you want to limit access. So with that out of the way, I just want to briefly talk about the principle of least privilege, which violating the canonical rule again, reading from the paper. In a particular abstraction layer of a computing environment, every module, such as a process, user, or program, must be able to access only the information and resources that are necessary for its legitimate purpose. So DevOps engineers often are people with heightened privileges. We generally want to avoid giving people more access than they need. So the question is, what is a developer's legitimate purpose? It sounds philosophical, but it's not what I mean. First thing they want to do is add features to existing applications, and they want to add new apps and services, and they want to fix downtime. And if you don't buy that last one, then you haven't bought the entire talk, so I'm not going to waste time justifying that. But assuming that you have limited these privileges in some way, which you need to do for security or stability or whatever it is, part of what you need to do as a DevOps engineer, I think, is think about how that reads to an application engineer. So you've just committed some code and you want to deploy it, and you can't do it because you don't have the appropriate privileges. How might that feel? I find this dramatized well by this dog who's extremely mad. Having to wait for someone with elevated privileges to help you really, really stinks. I was an application engineer for a while. I still dabble in application engineering, but now I know enough DevOps that I am sort of in this weird middle ground. Anyway, that's not important. Point is that it can be extremely upsetting. Furthermore, being told that you can't use certain tools as a matter of policy is really, really frustrating. I was working on a client and we created this great ability. We gave developers playgrounds, right? It was amazing. They could spin up the entire platform by making a pull request and just running a Jenkins job. It was beautiful. But they didn't have privileges to get logs from the application. so we were like, great, you can check out how your thing is performing in a production-like environment. And then they couldn't debug issues. And so that we spent a lot of time getting logs for people. It was terrible. Anyway, that's one way it can go. The other way it can go, which I think will resonate with a lot of DevOps engineers, is like this. You're really, really happy that you don't have permissions. As a consultant, there's no better feeling than surrendering root access on my last day at a client, where I'm like, great, don't have to worry about that anymore. Fantastic. I can just leave my laptop anywhere. And having limited permissions is also really beneficial for learning sometimes. So if you have read access to a Kubernetes cluster or read access to some set of AWS resources, that's really, really nice because you can run all the commands you want without fear of causing any damage. So that's just something to think about when you're thinking through limiting privileges. Is sort of the experience that an application engineer might have. Do they feel like you're shutting them down, or do they feel like you want them to be able to do things safely and you've got their back? So pretty quickly, just want to go over facilitating responsible access, a summary of the last couple slides. You want to give developers the power to make necessary changes without compromising security and stability. The best way to do this that I have come across so far is the buzzword GitOps, where you maybe you're using Terraform. Every time that Terraform code is merged into the master branch of a source control repository, you go ahead and run Terraform plan and Terraform apply. And this allows basically anyone to go in and say, I'd like to add these EC2 instances. And then someone from the DevOps team can say, okay, yeah, seems reasonable to me, and then you merge it in. And that goes a long way in saying, giving the power to create new infrastructural resources without, actually giving the credentials necessary to do so. If that's not possible, you want to be extremely available to grant permissions and perform sensitive operations. I wouldn't underestimate how important this is. If you can be in Slack and just have a Slack channel, so I know it's important to make tickets and so on and so forth so you can track your work. But for stuff where it's can you please set this environment variable on this server? Just make this as easy as possible because then the developers will know that you're on their team. This is extremely hard and also DevOps' job. I don't want to trivialize how this slide. This is kind of the whole deal. Let developers make changes safely without compromising stability or security. That's the entire industry right there. So I don't want to trivialize it, but I just wanted to point it out. Okay, so this is actually the same picture flipped in on itself. There was a dress your dog up for work day at some sort of military base, and there's this dog with a really long tongue. Love it. So once you have empowered these engineers, right, the important thing to do at that point is to trust them to maintain the platform. And that's really, really, really scary. But I think there's some ways to make it a little bit less scary. It says everyone reports for duty because it's like a military dog kind of thing, but it's also like everyone is being responsible for the health and performance of the platform. So how do you do that? The first thing that I would suggest is making alerts extremely public. I have not successfully lobbied an organization to put downtime alerts into the general channel in their Slack, but one day I'll get there. But when an alert happens, you don't want to, 10 minutes left. Once, you know, if an alert goes off, you don't want it to go into a DevOps channel or an alerts channel. You want it to go off in an extremely, you know, the engineering developer channel or out to your engineering, you know, mailing list or what have you. And in that way, it's like, it's not just this subset of people's problem, it's everyone's problem. And when someone acts the alert in like PagerDuty or whatever, I find it's like very good to annotate like that original message being like, oh, Sam acknowledged this message. And the next thing that you want to do is put every engineer in the on-call rotation. This is an extremely difficult thing to do because the engineers are not going to be capable of solving most of the problems. You think that adding more people to the on-call rotation is going to reduce the amount of work that you have to do as an on-call engineer. But in practice, what happens is the engineers get paged and then they escalate because they don't know what's going on. But nonetheless, if you put every engineer in the on-call rotation, that means that they are now responsible for the performance of the application. There is nothing, and I speak from experience, there is nothing that will get you to write safer code than being put on call. Yeah, like 4 years ago, I was working at a place and the DevOps engineers were like, all right, cool, like we're rolling out like a on-call rotation for every application engineer, including front-end engineers. And I was like, this is terrible. Like my weekends are ruined. And then actually, I just ended up writing better code and learning a whole lot about the infrastructure. And like that led me to, you know, be more interested in DevOps. And I was making smarter choices as an engineer as a result of this choice. So if you want to talk about how to make that happen, I'll be available after. But yeah. So last slide of any real content is that I want to urge the people in the room to trust developers. I know this can be hard because developers can sometimes bring down our applications and make us wake up late at night, all that kind of stuff. But I do think that like pretty much anyone else, software engineers feel a lot of responsibility when they're trusted, and they don't feel responsibility when they're not trusted. I don't know if you have ever had a boss that like checks everything that you do, but it is extremely demotivating, and you basically start putting in the bare minimum and doing like not your best work. I think the same thing kind of happens with software engineers, where if during an outage, an engineer is like trying to be helpful and trying to like debug the problem with you, and you're like, please leave me alone, I'm trying to fix the website. Or if you're like, don't worry about the deployment step, just click this button, they'll begin to think like, hey, I'm not responsible for this. So I would say go to the exact opposite. I'm going to skip this bullet point because I've spent a lot of time talking and I want to leave some time for Q&A. So thank you for listening. This is a dog on a laptop, and this is the Q&A slide. Thanks.
So for everyone who has questions, I will walk around and give you the microphone so we can capture these in the recording.
Looks like I'm getting off easy.
And if no one has questions, that's great too. There's always the hallway track to continue discussions.
Hey, how's it going? I'm Nick. I just wanted to follow up on the on-call rotations. You said that you would put the software engineers on call. What kind of responsibilities would they have with DevOps?
Yeah, so it was the reverse of what you said. I was put on call. But yeah, so basically, it was really amazing. I was working with, there was a SRE DevOps team at the company. and they were like, we're putting all of the engineers on call, and they basically made runbooks. So for common issues that there might be, they made like 3 or 4 runbooks, and then basically there was a set of alerts that they had sort of refined over time, right? So their SRE DevOps people, they're like, all right, well, this alert is annoying me. This alert is waking me up. So after 6 or 7 months, doing that, they had culled the alerts down to a reasonable level, and then basically you just got added to PagerDuty, and once every 6 weeks you were on call, and it was really amazing. I worked with this guy, Pete, who I think he's from Seattle. Anyway, Pete was great. But basically, the engineers would be the first on call, call. And so you were the one that would get woken up, or you would, it's like 2 p.m. or whatever. You get paged because their website is having trouble or whatever. And then it's like, all right, look at this alarm. And then you'd look at the documentation. It's like, all right, well, if the RabbitMQ alarm is going off, you probably want to check these 4 or 5 things. And then if the alert resolves itself, then don't worry about it. And if the alert doesn't resolve itself, you can try these things, or you can just escalate. And I think what made it like really, really good for me and for the engineers is that like Pete and the other SREs were just like so willing to help. Like I escalated constantly because I had no idea what I was doing, right? So I would escalate, and then they would always be like super helpful. They'd be like, all right, well, like what have you looked at so far? Let's check this out. So it was like a very positive experience in that it was supposed to be for learning, and it got every engineer like closer to the infrastructure. So
Cool. Thanks.
yeah. I think there's one back there.
I agree with everything you've said. But having worked for both startups and large companies, I can tell you that you have to find applicability to that particular organization.
Yeah.
Give you an example. Weather company, we had a 24-hour knock. And part of our application deployment process was to predefine all the alerts that we could get. And then when those alerts came into the knock, there was a reference that those guys looked up to see whose area of responsibility that particular alert pertained to.
Right.
So you had an area of responsibility as a primary, and you had a backup. So if you were on vacation, they called the backup, and they had everyone's schedule in front of them. So if something you were responsible for went off an alert, you got called. So
Right.
it wasn't an on-call rotation. It was you were the one that got called.
Right.
So everyone was responsible for their particular piece of the architecture. Instead of trying to hunt down and escalate, the person who could fix it was the person who got called first.
Yeah. That's super interesting. I've never worked in that way before. I've mostly worked at smaller companies, so maybe that makes sense. But yeah, that's super interesting. Did it work well? Absolutely, he says. All right, cool. Yeah. Right on.
So similar question. How do you deal with the flack you get from, if you throw the alert in a really visible channel,
Yeah.
the 80 people who are like, that's not me?
Yeah. If you, again, I've not had success like actually getting us into the general channel, but one day. I think if you have like an on-call engineer, you can even annotate the original alert being like, hey, this alert got sent to, Dave. And then, yeah, if there's flack, then it's like, okay, like Dave's on it, like Dave is the primary on-call, and Dave has acknowledged the alert and is looking at it. And if people start freaking out, as is likely to happen at a SaaS company, that's okay, right? That's yeah, exactly. And at least it's not just like the DevOps team getting the flag, right? It's a distributed, flag reception system, which is, the next frontier in technology. It's not just like the same 3 people that are like, oh man, like the DevOps team sure can't keep the website up. It's like, no, like the engineering team is like responding in good, like in a timely fashion to incidents, and that's good. So yeah, I don't know, no good answer besides like, yeah, the distributed flag system, yeah.
And that's all the time we have for Q&A. So let's give Sam another round of applause.
Thanks.